Hello. Welcome back. Oh, as soon as I hit start stream, my dog starts barking at somebody. Oh, okay, thankfully I'm moving soon, so to a nicer place where I don't have people walking by the windows all the time. Hopefully you can't hear that. Today, this is going to be a once-off stream, I think. If it's good, we'll continue it, but I want to try and finish a project within, I don't know, an hour and a half maybe. I just got to check to make sure that everything's working, and I'm not just speaking to nobody. The stream did not come through last time. Cool, streaming again today. Yes I am. Just for a little bit. I'm kind of in the mood to do it. Like I said yesterday, I want to try and do them twice a week. This will be my second one. We'll see how we go. I will get to a point where I'll be very consistent. But anyway, so the start of this, I haven't thought too far ahead, but what I want to do is like a first-person game. It's not a shooter. It's a first-person game using SwiftUI. And I want to do it in such a way that... So basically it's going to be like a maze game, right? Tap left or right of the screen and you can navigate through a maze. And you can navigate by using like vision. You can navigate by listening to sounds. And you can navigate by like haptic feedback and stuff. So I kind of wanted to build an app that like anyone could use, and no set person has like an advantage over somebody else to complete it, right? So if we get started, like I might have to run out for a second if that dog keeps barking, but we'll see. I had him in here a second ago, but he just sat over there with the toy in his mouth, like wagging his tail, like barking again. And I played with him all day. Don't worry about it. So he's just very excited. Right, so most maze games you'll have like the map set up to be, I don't know, like level 1 or something would have like a 2D array, right? So you have, let's say we use symbols for this, right? So maybe we have X, 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 and then we have, well, let's close it in, right? So let's say our map is like a 5x5 grid, right? And then the next level we would have something like X. These are the walls, right? And then we would have, I don't know, like if we wanted a corridor of some sort, we put a 0 there or something. Then we go X, X, and so on. Let's do another part of a corridor. Let's say a symbol for the user, like the player, could be like an A or something like that. 0 could be an empty hallway. And let's just do this again. We'll do like a 5x5. This is just I'm just sort of giving an example here, right? So this is probably not how it's actually going to be laid out. And then what I'll do is I'll add another one. And then the last one here might be like D for a door, or the end of the level. And so what you would do is, so the player would begin here, you'd feed the map grid into your code, and that would set up the level. And so you would be the player, and you can walk forward twice to the door, to the exit of the room, right? And then we load in map 2. So that's about as far as I've got. So like I was driving around today and I was thinking, how am I going to make this work? And I was like, well, I can do a 2D grid. There's, well-known math things you can do for like checking what value is in the next grid over and stuff, so you know what to show on the screen and things like that. I might have to look those up because it's been a long time since I've done that. So like navigating in a grid, so like in order to get to, to go from A to up here, there's a little bit of math you got to do based on, the number of items in the column and all that sort of stuff, so you can get the index of this, so we can pull out whatever value that is, if it's a wall or whatever. Now, the plan that I have is to make it as simple as possible. So this isn't going to be a very exciting game as such. It's just a maze. I want to use like solid colors. So I want to have... So let's see if we can rotate. Can we rotate the device here? So I can show you landscape. Oh, let's turn that on. Is it not Oh, come on. Oh, because I've got I've got this in there. Okay, hang on. Okay, let's see it. Let's see it do its thing. Come on, reload, and we'll do a rotation. Hopefully. Yeah, cool. So you can kind of see my cursor here. So what I want it to be like is maybe split into 3, or we can use some sort of gesture. So if you tap once on the right side, the player will turn, and then tapping in the middle or double tapping anywhere on the screen will have them walk forward. Now here's the catch, right? This is going to be incredibly difficult because what I want to do is just have solid colors. So like a solid color, like red would mean a wall, right? So if you turn, if you double tap and you see red again and there's like no animation, then you're still looking at a wall. But there's no indicator of that you've turned besides haptic feedback. Like it'll vibrate when you've done a turn. It'll vibrate when you walk forward. It'll vibrate if you try and walk into a wall. All different, right? And then the sounds will be different too. It's probably a really dumb idea, but I wanted to try this out. I thought it'd be kind of fun. So let's give it a go. So first thing I need to do is kind of work out what elements are going to be in the game. And I think this is easy enough to do with SwiftUI because all we're doing is like swapping out views and stuff. So nothing too crazy there. I think we can add things later like animations of and other UI elements and stuff like that. But like I said, I want my maps to kind of be like this 2D grid, and then we just like query what's at each of these positions as the user like does a turn. If they're here, let's zoom in. If they're here and then they say like the double tap and move forward, we check that they can move forward into this spot because there's a 0 they can, and then what will happen is it would be kind of like this. We replace it, and the reason why we replace it is because we want to be able to like let the user navigate backwards as well. Okay, so we'll keep this a live thing. So this will be the map. And then what this also means, it'll be easy for me to generate new maps because I can just keep creating them, right? And I can just put these all in a file. I can put them in JSON or something and just make edits to them. Once you get to the door or the exit, could be an E for exit, it will just load up the next one in the series. So really the entire game would actually be a 3D array instead of a 2D array, I guess, because we'll put all these map 1, map 2 into an array themselves. Yeah, I think that's going to be cool. How long have I been working on Swift? You're less than 6 months. I started with Swift when it first came out, which was the same time when they released the first Apple Watch, because I remember my first app in Swift was a watch app. 2014, 2015, something like that. Yeah, I've almost completely forgotten Objective-C. Okay, so what we need, let's write some notes here, okay? So an hour and a half, I don't know if I'm gonna be able to do this. We may have to split this up into 2 streams because I have to go somewhere after this. So, okay, so first of all, we need walls, we need an exit, we need a start, right, where the user is going to start. We need an empty spot. I kind of think that's all we need to start with, like on level 1, because it'll just be like a complete hallway, and then the next level will have like a turn in it, because it's gonna be difficult, right? And then the level 3 will have, I don't know, maybe we can add like a button in there, or like something you have to push against, which is different color. So let's start working out what the different colors are. I reckon we use an enum for each of these, and then we can just keep adding more enums. Add more cases, right? So what do we call it? We call it, it's almost like a tile, I guess. And then we'll have our wall. We should do this with, should we do this with numbers? Now let's do a string. We might change it. We'll see how we go. And then what I want to do is like denote that with like a capital W for wall. And then we have like exit, which will be a capital E. And that way we can convert these from the JSON directly into the enums. I'm just making this up as we go along, by the way. So who knows? If you skip forward 30 minutes, this might be completely different. Okay, start will be S. Oh, we also need where the character is. Or player. Let's call it P for player. And we might not need the start then in that case. Because we'll just put the player where the start position is. And then we'll have... we have empty. Should we do E for empty? Is there anything else? Or floor, F for floor. Just say empty, so they can go anywhere. Okay, so that's the... Oh, we already got E. Okay, we need floor. Or ground. Because we might have something else that you could walk on that's not ground. I don't know. I think that's good for the game tile itself. It's not a visual thing in this sense, I guess, because, I mean, we're going to have colors here too. So if we say color, we'll use color, and then we'll do a switch here, and then we'll just pass through the self, and we're just going to pick some colors for each of these. And so that means each wall, I don't know, what's something nice? You'll be looking at it most of the time, I guess. Use dot for floor. Oh, I hear you. Yeah, we could use symbols because we've got the string up there. Yeah, we don't have to use letters at all. Like, we can use plus, the plus symbol. Yeah, okay. I'll have a think about it. We can change them later. It's okay. Colors. So the wall, I think the wall should be maybe blue. Can we get away with that? We can make changes to these later, like you know, tint it so it's not just like pure blue. The exit will be. Do we have gold? Indigo? It's too close to blue for an exit. Oh, and then in future, to help with like color blindness and stuff, what we could do is like have patterns and stuff on them. That'd be pretty cool. Okay, so exit will be, I guess, green. The player doesn't need a color because we're not going to see the player. And the ground. A ground tile. Now in this game you're not going to see, yeah, exit green, yeah, perfect. So the ground you're not going to see, it's just going to be solid color in front of you. That like everything's going to look like a wall essentially. But you need to sort of like know that the ground. Let's go let's go brown for the ground. If you're heading in the correct direction, the entire screen will be this color, and we'll have it as, I don't like brown. I don't know about brown. Is teal too light? I don't know. It doesn't matter. I think I want to get into doing some game stuff. So we've got our game tile. Let's just create also just like map 1 with these elements in there. And then we got something to play around with, right? So what we've got here is a wall. Hang on a second. It doesn't really matter how large we make this because, I mean, whatever code we write for it is going to we've got that there. Whatever we code we write for it is going to work fine anyway. All right, so we'll grab a bunch of these. So what I want to do is like 5 by 5. Is that right? That's 6. Doesn't matter. And then we'll have our hallway. So if it's 6 long, let's go with P for player. We'll probably need to do some checking at some point, like to make it more robust. Like make sure I don't put the two P's in there. because then there's two players, unless I want to like randomize where they start. Here we've got the ground, which is G, and then we'll just have E for exit. And I think we can get rid of one of these just to clean it up a bit. Yeah, so we got player, we got ground, and we got exit. And we got all these walls. And I think that covers everything. 1, 2, 3, 4. Yeah, so we got all of these in our first map. Okay, so we've got our map set up. The initial starting position. So we need to keep track. How are we going to do this? So anytime, because we're using SwiftUI, anytime our map updates, it's going to redraw the view. So what we want to do is maybe put this into like a model or a state that we can change up. So like, for example, what we could do is we'll call it current map, because we'll load them in and swap them out as we need to. And we'll just go map 1. And then this means this is now editable, right? Because we've got this set to a var, so we can change this now. So now all we need to do is like process what we see on screen. So I guess if we got a V stack, we need a Z stack. We need a Z stack because we're going to put some buttons on the top of the screen. Or we could use an overlay. So the background, let's go with color red for the background. Let's do a refresh on this. Let's see how we go. Okay, cool. No padding. And then we'll just go ignore safe area. So I want that on the full screen. And then we need the controls to be done in such a way that you don't actually need to see them. Because remember, we want this to be for people who can't see very well and people who can't hear very well. And if you've got both of those, we want to have the haptics as well. So, and then obviously anyone who can see and hear well has no advantage over anyone else who can't. So that's the whole point. Okay. So we got the red. So what we're going to be doing is replacing this color with whatever position the user is currently at on the map. And what we need to do, we need a way to track the direction, because the map has no way of doing that for us. So like if I'm here and I move forward a step, that's fine because I'm looking in this direction. However, if I want to look if I turn around and look down here, I should see a wall. The color should change. And the color needs to be based on the position ahead, not the one that I'm on. Right? Would it work if I was to say I'm here? No. Making Doom? Doom was 2D, right? Doom was like flat in a 2D. Well, maybe. We'll see how complex I can make this thing. Okay, we're going to start simple first. I think I need to do a little bit of math now with this. I'm going to have to borrow some from somewhere else online. Yeah, so it needs to be based on the direction. So we'll say the direction is north. Let's do another enum for the direction. I don't think we need to type this. So we'll go north, south, east, and west. Am I doing this right? I feel like this is correct. And then we'll set an initial position. Oh yeah, so the map's going to have the direction the user's facing as its starting condition, right? Unless I just make the assumption that it's always going to be facing east. And when I design my maps, the player always starts facing east. So what that means is I can just say state, I would call it player direction. And we'll just say it is, they're always facing east, right? So the initializer for this, and maybe later on I can come up with a way of changing that up, because I would like, you get to the exit and maybe you're heading south. Interesting. But I can always redirect them in that direction once, like I can say this could be a ground tile here. And then here could be like the exit, right? And we can make them turn, and then they're facing south. This will remember that they're facing south when they go to the new map. So I just got to make sure I remember. And if they're not, they can always just turn around, right? Like it doesn't matter if I start facing a wall. Yeah, doesn't matter. Let's keep going. Okay. So we've got the player direction set up. We need the buttons over the top of this. So we'll have a H stack for those. We can do buttons or we could do gestures, right? A state object, maybe. Yeah, for keeping track of that so it doesn't get recreated, is what you're saying. We'll see how we go. We'll see how we go. We're only doing one level first. I might not do... Could I do H stack or could we do... No, this will be fine. Ooh. Even a swipe could work instead of a tap. I don't know a whole lot about accessibility though, so I wonder if what's easier, is a tap or a swipe easier for people? Probably a tap to turn. But then what if you accidentally tap and you turn and you won't know because you're facing two walls one after the other because they're the same color? I kind of like the idea of a swipe. Swipe left, swipe right. Double tap to move forward. We can try that. We can try that. So let's do a gesture. Got a swipe gesture. What am I doing wrong here? Form to gesture. Oh, okay. So what we need to do is change this. I'll figure out what the API is in a second. Nope. On tap, we got long press, simultaneous gesture. Guess. Swipe action. Swipe up to move forward. Oh yeah, we could do that. Yeah, we could do swipes. Let's just do that. I'm gonna have to do a little bit of a search here. Swipe gesture on, I'm just on another screen right now. Swipe gesture on SwiftUI. How to detect swipe up, down, left, right. Excellent. Here we go. Oh, it's gonna be a drag? Okay. I guess we're doing drag gesture. Is that the only one we have access to? These are from 2022. I would assume that we got some better ones here. Looks like it's just drag gestures. So many different ways of handling it. Yeah, I kind of get it. I kind of get the reasoning behind this. Okay, let's just grab one of these. Okay. Drag gesture, minimum distance. No, go 0, right? Coordinate space, local, I suppose. And then on ended. Yeah, so then because we get a value back, we have to like use that value to get the direction and stuff, right? I think. Let's make this a little bit wider. We'll do this all in the same file, so we can make that a little bit larger. That's fine. Okay. So the math here is like if... Actually, let's just see if this works, right? And then we'll do a replay of this, open up this up and just go to the, yeah, we got preview selected. Yeah, okay, we're getting a printout down the bottom, so this works fine. This is cool. If we find that it's like a little bit weird, we can change it. So go to the translation, width is less than 0. We've got, so player direction. Oh, okay. Ooh, okay, so we can't just like say east to west. We have to rotate. So if they swipe, so this is left. If they swipe left, they need to, okay, how are we going to do this? Because I don't want to run this through, because what we could do is like, if the player's facing east, they will turn to the north. If they're facing north, they'll turn to the west. If they're facing, I kind of want to, if there's like a clever way of doing this, because we would have to place this in every if statement, and that's just going to get, so we'd have this nested thing here. We'd have if player direction is east, we go player direction is now equal to north, right? Else if player direction equals to north. It's been a long day for me too, so there's probably a much easier way of doing it. We're going to go west. You get what I'm saying? Like maybe an enum isn't the way to go for this. Because what I'm thinking about now is how can maybe I can combine, because I've got to go through this process, and then what I've got to do is somehow translate their direction to a point on here. So basically our positioning is kind of like the spot we're reading from will be, let's say the player is here. The spot we're reading from, if they're facing east, would be G. And if they face north, it'd be W. So we need to work out how we can translate the player direction into values that we can use here. I don't know if it'll help, but I wonder if maybe we need some values assigned to these instead. Let's just brute force it for a bit and see how we go, right? So I haven't got a lot of time, and I haven't, like, to do it properly, I've got to spend some time thinking about this. So let's just keep going with player direction. Equals west. We go player direction south, and then player direction south. We turn them back to east. Okay, so that's if they turn left. The next step is if they turn right. Otherwise, we go if value translation width is larger than 0. We put all these in, but we just gotta like, so if they're facing east, we set it to south. If they're facing north, we set it to east. If they're facing west, we set it to north. And if they're facing south, we set it to west. Okay, so this will be right turn, and this will be left turn. It's probably a better way than this, right? And then we go forward. And there's no way to go backwards, right? You just turn around. So if value translation dot, I think it's height, what we got, it's less than 0, because you're going down. That'll point you up, so that's forward. We may do a double tap on this instead, I think. And then we'll just say move forward. And so this code here, whatever we put in this block is what will change. It will update the map and move the character to that spot. But what we need, the main thing what we need to do here is, right, so what we've got to do is check if spot in front is free. And so like if empty, move forward, if exit, next map, right? That's kind of what we need to do. Hello. A game built in SwiftUI. This is ambitious. Good luck. Trust me, it's not. It's the most simplest game I can come up with. I have another video where I did like this rope. Let's see if I can find it actually. I'll show you on stream real quick. So I worked out that SwiftUI can do some physics. Let me see if I can find. I've got a few videos. Let's see if I can find all these. Okay.
There's nothing more powerful than.
Oh, I've got ads. Hang on a second. Really going for it. So what happens when you open a browser you're not logged in as yourself? I got YouTube Premium, but I haven't got it. Yeah, okay. So hang on. Let's see if we can find the part of the video. Where is it? You can see that. So it draws a couple of strings and they're connected by these lines, like these dots, each of these nodes. And then go forward a couple of seconds. And we got this like dangling rope that's like fully animated, right? And it's stretchy. So I've done some. This is all in SwiftUI. So I've done some physics stuff like that when SwiftUI first came out. I'll put the video in the chat. You can have a look at that later or something. I don't know. So I know SwiftUI is capable. It redraws the screen fast enough for that kind of thing, right? And then we can also pull in stuff like SpriteKit if we wanted to, and all the 3D stuff as well. So in another video I did particles. I used particles within my SwiftUI views from SpriteKit, which is kind of cool. So this game is going to be very basic. All right. So we've got we're going to check if the spot in front is free. If empty, move forward. If is an exit, go to the next map. It's pretty simple. The problem that I'm going to have here is translating this direction value, translating the direction value into like this here, this here, this here, like the north, south, east, west, if the player is here. Mutate the raw value +1. Move left, turn raw value -1. 4%. Well, I'll do the mod 4 and all that. Yeah, okay. So there's some math there we could use. You can give your 0 to 3 northeast, southwest. Yeah, okay. I see what you're saying. So instead of keeping track of like this here is like, get rid of these and we'll just have a number up here instead. I kind of get what you're saying. Let's go with the walking forward thing first. That's going to be the easiest, right? And that's all you need to do on the first map anyway. You don't need to turn. So what I want to do is check if a spot is free. So what we can take a look at here is we got to grab So glad I'm back. I missed your last stream, and we'll have to catch up on this one later. Just wanted to say keep doing what you're doing. Also, I'll be linking my Patreon to my new bank account. Oh, thank you. What's going on here? New to this channel. Okay, so I'll give you a quick update. So I'm trying to build a game, like a maze style game in SwiftUI, but I want it to be accessible to just about anyone. So the maze is like you just got a solid colored screen that you look at, and you swipe left or right, and then you get presented a different color depending on what you're looking at, right? So if you're looking at a wall, we've got the color blue. So the screen is always going to be blue. If you swipe, so for example, if you are this P player, this is our map grid, right? If you're the P and you're looking at the W, which is a wall, and you swipe left, you'll look at another wall. The color won't change on the screen. Give my direction in cases raw values. Okay, yeah. You know what? I'm gonna see how far I can get first, because that's sort of like refinement, I guess, in my algorithm. Like, I'm gonna keep that back in my mind, because I think you're correct that that's what I need to do, because then I can use those on to navigate the grid as well. But I'm gonna take one step at a time, because I haven't got a lot of time. So, no, I can't hear you. Why would I be able to hear you? You're just, it's text. Anyway, so to explain what else I'm doing, yeah, so it's just gonna be solid colors. You'll get audio feedback when you do a turn, and what you're looking at will provide some audio feedback. So if you can't see very well, you'll be able to swipe on the screen and just navigate the maze with sounds only. If you're not great at seeing or hearing, you'll be able to navigate with haptic. So I'm gonna do like different haptics depending on what you're looking at. And that's the extent of it, really. Yeah. So it's pretty simple. Like, we're just using views. I'm going to switch between them. But I'm starting to get a little bit stuck now. What I want to do first is just to get the player to be able to navigate forward and then go to an exit, right? So that's what we're going to do right now. And I just can't remember what the math is to jump from like this position to this position, because what we need is an XY value, right? To know what spot to change. So this is the map that's live currently. So this is map 1, which is I've put down here. So this is like the hard coded values. Player will start here. The current map, when this map changes, and it will when I move the position of the player, it will redraw the screen, and then we'll go through and change the colors and stuff that we need, which is here. So we'll pull this color out based on the user's position. Okay. And I think I need to recalculate that. So we might have like, I don't know, current color, right? And we'll just change this to current color, and I'll do like some sort of processing to update this, and that will update what we see anytime the character moves. So down here in this section, this is the forward. So when they swipe up, let's do a I'll do a print, and I'll go player directions, just so you can see what's going on, right? So if I swipe right, we've turned to the south. If I swipe right again, we've turned west, which makes sense. Swipe right, we turn north. Swipe left, we turn west. We're going backwards, right? And we can just turn in a circle by swiping. And if you're completely walled in, you're just going to see one color. Your player position should be the state. Your map is constant throughout the entire level. Yeah, I could do it that way. I did think about doing it that way, but I figured if I'm just updating the map, because what I was also thinking was in the future, we might have like a button or something you can push, like a big block that can be pushed out of the way if you just keep walking into it. And then that would update the map. And I feel like that might be a better approach, because then otherwise I have to keep the state of where the blocks are in the level, right? Like I want the level to be the source of truth. So like when you start, the explanation is going to be the entire video because it's such a weird concept. Each turn, each tick of the game, right? The app will read from the map over and over again. Every single time you make a move, it reads from the map. I think keeping the map as the source of truth is the way to go. depending on what I want to do later with it. Okay. PGG. Okay, yeah. So we need to step forward. So what do I Google? Like navigating a 2D array? So I think what I might need to do, I have a book somewhere. It's in a book. I wrote a book. I wrote a book about running simulations in Swift, right? And I do this exact thing, but I don't have it here. It's in the other room. Okay, it doesn't matter. I'll just look it up. 2-dimensional array. All right, let's do ChatGPT. This will work fine. I'm sure it will. I have no idea what you're going on about, by the way. We got someone here crashing the stream. Is that what they're doing? I don't even know what they're saying. Okay. ChatGPT, I'm just typing in. Okay, so it's on another screen. Just bear with me. I have a 2D array that represents a game grid. I would like to some Swift code that will allow a player to let's see what produces for us. Whew. All right, I'm gonna grab this and I'll just dump it in here, and we'll just have a look through it together, see what if it's useful. Okay, so we've got a number of rows. We don't need to worry about that because the grid itself defines how many rows and columns there are. And then the game grid, it's just creating a regular game grid. It's just these repeating values. So it's got an array inside an array with repeating values. Okay, so player position. So they've set a start position, row 2, column 2, which is here, which would be here, where that G is, I think. And then we've got the function to move the player in a specified direction. So it looks like we've got plus 1, minus 1, all that sort of stuff. That's kind of cool. This is what I was thinking as well, and I'm sure that's what you meant as well. So we give them different values and stuff. Check if the new position is within the grid boundaries. Oh, this isn't quite right, is it? Yeah, so this is going on with just a regular, like a player position here. It's just moving them. I think I'm just gonna have to do this myself. That's not very helpful. All right. Check if spot in front is free. So what we need to do is move forward. I'm gonna have to brute force this. If player direction is equal to east, then we'll just add a value. So we can go to the grid. If we got to keep track of player X, Y I don't think we're going to I don't think I'm going to get very far today. We'll use a size value, so we've got x and y. Okay, thinking. So we need to get the current position from the user. So current position, and then we will have. We got to iterate over the grid and find where they are, right? So which would be CG size. So we can remove this for now, and then we'll just go for. We're gonna have to do this each time they turn, so we might have to like pull this out into another function at some point. So, but we're just doing the moving forward to start with. I'll be happy if we finish today with just like moving forward one spot if it's empty. You need a proper map model type that will keep track of player position and direction and provide API to turn and move. Yeah, and that's what I'll do. So I won't put this. I don't think I'm gonna put it in a separate file. I'm just gonna create some functions and stuff down here, and then keep track of the state up here for all that. But yeah, I get it. Probably do need to keep track of the player position and update the map at the same time, because recalculating it each time is kind of like a bit silly. We'll get to that. I think. Yeah, you're right. So for x in, we don't want map 1. We want current map. What is his level in iOS? I'm a beginner. I want to know. What do you mean, like my level? Like how good I am at iOS? I don't know. I've been doing it for like 12 years, but I don't think I'm very good. Current position. No, we need current map. Current map. How we got this set up? We got X or Y first. We've got. What works easier for my brain? Let's call it for row in current map, and we go for column in row. Okay, if current map, and then what we do is we go row column equals p, then the current position will be the row and column, right? So should we just make this a tuple? Can we do that? Does that work? Not going to yell at us for that. Excellent. So what we could do is make this row and column. Cannot convert value of type string to expected argument type int. Oh yeah, right. So we need to, oh man. All right, so what we need to do is change this to like the count, and then we're gonna go count. Okay, what we got? Value type of int has no member count. This isn't int. We've got, oh yeah, it is too. Okay, so we need, I'm getting there. I'll get there, people. Don't worry about me. Oh yeah, this is annoying, isn't it? Oh, you need to go? Okay, see ya. SwiftUI 5 architect, yeah. Okay, so we need, oh my god, my dog's at the door yelling at me. Give me 1 second. Come here. All right, here she is. There we go, in frame. The other one is outside, chewing on something, a bone or something like that. Oh, I'm an idiot. This is what happens when you're trying to work quickly. Here we place in the row. So we got row. So this will be a number. So it starts at 0, right? All the way up to 4, I think. 0, 1, 2, 3, 4. So that's for each row. And then we've got a number for the columns, which is in the other direction here. So we've got 4 row. For each row, we're getting the integer for that. And then we're passing it in here so that we can get the number of items in each column. We might have to reverse this. My brain isn't working today. All right, so we go var here. Variable current position was written to but never. Okay, cool. So what we could do is try and print this out and see if it's correct, right? So let's say current position. Let's give this a run and then just see. I'm gonna swipe forward. What have we got? Before being initialized. Okay, yeah. Just go 0. Yeah, that'll be fine. I'll fix this up later. I don't want to initialize it to a 0. Okay, so let's check out our print down here. Let's clear that, and then we'll just go forward. We got 2. We got 1. 2 and 1. So we're on our map. 2 across. Oh, yeah. Okay, so X is incorrect. So we got to flip these, right? Because we need to go across. We need to go across 1, which will be X. So 0, 1, and then the other way around. So I don't know if we can get away with this. The math might break if we just switch it there. I think we might need to switch them up here. That's okay. So if we run this again, 1, X is 1 and Y is 2. So this starts at 0. 0, 1, and then 0, 1, 2. So we've got that correct. We've got the coordinates of the user's location. So what we need to do now is we've got the direction and we've got their coordinates. At this point, we need to check if there's a spot in front of them that is free. And in order to do that, if the player direction, if they're facing east, which is to the right, we need to add +1 to the row value of where they are. So what we can do here, I will write a function a little bit later that makes this a little bit easier, because there is a trick of navigating a grid, which I did put in my book, but I don't remember how I did it. I'll check that for the next one. I feel like we're going to do another stream on this because this is too much fun. So if we're facing east, I need to add 1 to the columns, not the rows, because we're not changing rows, we're adding a column. So let new position, or we can call it like potential position because we might reject it, right, if there's a wall there. So let potential position equal I'm gonna have to say player, not player direction, player current position X, no, so X +1, and the other one, the Y position stays the same. So we go current position dot Y. Okay, so that checks the spot in front there. So then what we need to do is if we say if current map, and then we say X and Y, we might need to flip these again because I'm not good with this. So we go potential position 0, which is X, and then potential position .1. We will clean this up, don't worry about it. I might create a new type for these directions and stuff. Type bool. Cannot convert value of type string to expected type bool. Is equal to, move that out of the way, this is very long. Let's say G. Cool. If it's equal to G, we can move the player to that spot. So this is getting too much because we got to do some swaps and stuff. Brute forcing is going to be very messy. Like, you can see all this. We can reduce that later. Okay, so what we need to do is replace the current position of the player with a G, because that will now be ground, and we will replace this G with the P. Vive. I meant the SwiftUI view architecture view for view. Oh, okay. Yeah. Oh, yeah, because I was talking about putting everything in here, in this one file. Yeah. Well, I'm hoping the game's going to be simple enough that I can get away with building it in like less than 500 lines of code, but we will see. Got like 40 minutes left, so let's see how we go. Yeah, so the current position on the map I need to replace with a G, but let's move the character. Interesting. I'm going to have to get a copy of the map here, change the copy, and then update up here so that it updates all in one go. Because if I remove the player from the map, even though I've got like, so right here I need to remove player, okay, or swap player. So right here I've got to go swap player with ground. So what? Okay, I'll show you quick what I'm trying to do if you're confused here, right? We're at this position where the P is. The player's here. What I need to do is now move them forward to this G. But in order to do that, I need to replace this P with G. And then I need to replace this G with P so that the player has moved forward a step. Any adjustments that I make to the grid is going to cause a redraw. And there will be a moment where player does not exist on the map. Okay, and so if we're doing a redraw during that, it's undefined behavior, like, because there's no player, we don't know where, like, what they're looking at. We only have their direction, we don't have where they are. So we're using the map as the source of truth here. So what we need to do is create a copy of the map, make changes to the copy, and then apply them to the one that is on our state up here at one time. So that way the redraw happens at once. So what we need to do, this is just going to add more code, right? So we got to go temp map equals current map. I'll have proper names for this stuff later. And then we can say temp map this position here where the player is, current player position. So we say current position dot x, current position dot y. It now equals G, right? Or whatever was there before. Like, we might have different surfaces. At the moment, we've just got like ground for G, but maybe the player will walk through water at some point. And so what we'll have to do is be a little bit smarter about, instead of just like force coding that to G, we got to say, okay, if this is water, then this needs to be water as well. And then what we're going to do is change the position of this, the potential position, to the P. So what we can do here is go temp map. In that case, your map shouldn't keep the player position. It should be in a separate state. Yeah, I hear you. I'm going to try and make this work though. I think you're correct. 0. This is weird. And we got like 0, X and Y. Like, this is not how it should be. I'm going to create some more new types for this, I think. Potential position dot 1 equals P. Okay. And then we replace the current map with our temp map, which will force a redraw. So we've just swapped the player with the ground tile that was in front of them. If I redo this, let's say, I think what I want to do at the end of this is print the grid. Okay, so when we load up, got any more prints? Let's remove the prints for a second. We might need to add these back in for debugging if this doesn't work, but I just want to compare the two grids side by side. So on up here, I'll just throw it up here. I just want to do a print of the current map. So we've got like a before and after we do stuff. It would be nice if these were on new lines. I think we can decode this because we're only looking at this section, right? So if we move forward, okay, let's slide down. Nope, nothing happening. They are facing east. Ooh, I swiped to the right and then we get this. Okay, so it looks like we've got 2 players on here now, not just the one. The update did not work. Or did it work? Oh, it did. It just did it in the wrong spot. It updated in the wrong spot. You can only see the one tile in front of you, or the front and the diagonally front, left, and right tiles. No, you can only see in front of you. Because I don't know how I would indicate that with sound. I'm sure we can make a more complex app later where you can kind of see like a bit of the walls side by side, like on your side, and then you can sort of see the front. But at the moment, it's just a solid color. It's going to be very difficult. Because the ground is, what do we say, teal. So let's set that to teal. Makes more sense that way. And it's only what's in front of you, not the spot you're on. It's what you see in front. And that will help with like when you turn and which direction you're facing and stuff. So it looks like we got the XY coordinates incorrect on the swap. So I'll go over this after off stream, because I don't think anyone's gonna. It's not very fun to watch me like sit here and mess and move around numbers and stuff. So I'll clean this up a little bit later. So let's cancel that out. Let's say we've got a new. Just hit enter and then we'll just refresh this. Okay, so this is our map. So we've got walls there, walls there. This is the row we care about. Then we got walls and then walls again. We want to move this P to where this G is. We want to swap these 2 around essentially. So swiping up doesn't work, and I'm wondering if it's because the device is on its side, and so I have to swipe. But it's weird because the directions and stuff were working fine before. We've got the same problem because I swapped the wrong ones around because I'm an idiot. So we've got Y here, we've got X here. This is the one that needs to change. Let's clear that. I'll force load the code again. So we've got this. Let's go again. Oh, that works now. We swipe up for some reason. Wait, hey, we got it. Okay, this is cool. Okay, so as you can see here, with our starting position was the player is here on this row, on this row, and then we've moved them forward a step, and then we've replaced the ground behind them with a G. So what we can do now is we can run this again. Come on, give me another one. Why isn't it working now? Oh, it's a bit of a delay, I guess. If we're going backwards somehow, how do we go backwards? Oh no. Surely this works. Come on. We've got PGG. I don't want to do too many swipes because it seems to break. We're going to need to have some sort of feedback on this. Let me swipe right. Swipe left. Nothing's working now. What's going on? We're facing east. We should be able to do a... Doing the height. If we swipe down, it should be giving us a printout here. Interesting. I'm not even getting a breakpoint. Is this thing broken? Let's try one more time. PGG. Swipe down. Oh, come on. Swiping in every direction right now. It's just reloaded itself. I don't think this is working in this simulator. Let's run it and see what happens. Let's not do it on my phone. Let's I don't know, 15 Pro Max. Let's see that. See how that goes. The preview is having issues. It'll take a couple of seconds to load up, so just wait for that. Gosh, it's the simplest app ever and it's taking forever. Okay. So, we've got the bar at the bottom there now. We should be okay. Swipe down. Up. Still not working. What's the issue? So we got on ended, should be triggered. It's kind of strange that it's not we got a breakpoint in here. So we're hitting a breakpoint. All right, let's find out where we get to. So if we have this in here, let's put these in. Okay, so that's down. I think that's to the right. That's incorrect. Oh no, we're getting this as well. We're hitting this too. Interesting. So I think what's happening is it's not getting into here, this section, because we're no longer facing east. So it's picking up a swipe. And I think if my angle is slightly off with the swipe, it's not going to work. So the way we're calculating this doesn't... It's probably not going to work for us. Yeah, so if I swipe left or right, we hit this point. But right now, if I print out the player direction, we're still facing east. No, we're facing south because this code up here modifies it before we get a chance to... I mean, I can fix that briefly by just moving this up in front of all this, but the thing is, when I want to swipe again, because I want to get this exit working today, walking in a straight line, and I mean, it's still going to be a problem. So what we need to do, have a look at this code that we've got over here and see if there's a better way of doing this. Yeah, okay. So here's a message here already. So this is where I took that code from. It says, this looks good, but it doesn't work correctly. Unless you're a robot, it is almost impossible to generate multiple responses. If you need that, your scroll view should work. Oh, the minimum distance should be greater than 0. Looks like there's a couple of others here. Create an extension. Nope. All right, we'll do a quick. We'll do a quick try of this and see how it goes. Check the value of value.translation. Since both values are non-zero, probably trying to move left, right, and forward at the same time. Yeah, I think you're right. Yeah. And if you're like even just slightly off, like, yeah, no, that makes sense, because the translation width and height are going to be very different. Yeah, this is stupid code. Why did I copy this? So yeah, the problem here is that the width and the height are going to be different. So what we could do is like kind of like normalize these a bit. So what we would do is find whichever value, whether it's the width or the height, that is larger. Because if the height is larger, then obviously we've gone from top to bottom. Like that distance is longer, that translation. Because if I swipe up or down to go forward, if I'm on a slight angle, it's going to have some width. It's going to have some width to the translation. It might be like 10 pixels this way, but the swipe up and down will have like 50. Right? We got to whichever direction has the most. That's the direction we want to go in. I want to see if this works though. If I swipe down, swipe up. This might be forgiving enough if I keep in a really straight line, because it's minimum distance is 30. So what we've done here, we've moved forward a step. So that works. If I swipe up, no, it's not going to work now because we've rotated. And this is the problem with this game too. You don't know if you've turned or not. Obviously I've kept the color the same, right? The current color is not changing right now, but you won't know, except for like a vibration or a color change or a sound. So I've got to do a little bit of what do we do here? So if let's do something like this, I guess. So we do a left turn. We say if the translation width is less than 0, so we've gone this way, well, whichever way you're looking at me, and the height is larger than it's less than 30. I'm not vibing with this one either, but we'll see how we go. It's the easiest way. The fastest way is to just try out a bunch of stuff, right? I'll fix it with my own. So I'm gonna go up. Let's try this. See if we get more consistent results. Okay, so all right, so we'll just focus here. So we got the P there. It should move across to here. Swipe up. Yep. We do it again. Are we facing the wrong way again? It doesn't work. It doesn't work. It doesn't work. Okay. Let's just print the player direction at the same time and see where we're going wrong here. Okay. Facing east. Facing east. This should be working, but it's not. Interesting. So there's something else going on here. So we want to take another step forward to the G because there's a position there that's empty. And I wonder if it's got to do with my code here where I've got these values mixed up incorrectly. Because the current map gets updated, and now the P is in a new spot. Check if it's within some tolerance of pi 4, pi 2, pi 3. Yeah, but you're getting all complex now. Like that's probably like what you're saying is correct, but I'm not good at as good at math as what you are, and I just know that 8 height width. Check if it's within some tolerance. See, what I was going to do was do a min max thing, like do a max thing, like whichever value was the highest, right? That's the way I was going to do it. But I don't think that's the problem here. I think now the issue that we have is now that the player's position is here, I've got something broken with this check. I think it's this check that's broken now. So we hit this, right? So because the potential position is the same, we want to do a +1. So we want to go over here. But this, I think this is failing now. Yeah, so we don't get into here anymore. And it's probably because I got a column or a I've got something mixed up. So got 0, got a 1. If I print out this position, I don't know if this will help, but we can try. So it works the first time. We move forward. So the potential position is 2 and 2. So that's what we want to go towards. So we want to go from here, which is 1 and 2. 1 on X, 2 on Y. And then we want to go to 2 on 2, which is fine, which we do. If we move step forward one more time, we want to go 3. So we want to go here, 3 and 2. So this is correct. And when we check that spot, if we go current map, potential position, if it equals G, we should be allowed to move forward, but it's not letting us move forward. Wait, when you're setting the new current map, you aren't setting the new current position. No, because we get the current position from looping through the map every time we do a gesture. So I figured this would work. Right? So we get a new current position when we search the map again for where that player is. So it should update. It should update. Let's do a refresh of this. Oh, sorry. I just realized that you guys couldn't see the sim off on the side of my screen. So sorry about that. So if I move forward, the current position starts at... Sorry. I'll move that down. Okay, so we'll do a swipe. It's 1 and 2, correct. 2 and 2, correct. And we want to move to... So it's picking it up. It's picking it up. So it is in the right spot. It's picking up where the P is. It's just when we swipe again, it's still in 2-2, but it's not moving forward to the next. So it needs to be going... Oh, yeah. There were a lot of viewers at the start of the stream, and now everyone's starting to drop off a bit. Okay, so we've got the P, the G, the potential position is 2-2. The current position will now be 2-2. The potential is 3-2 because we're going across to 3. Swipe again, and it just gets stuck on 3-2, 3-2, 3-2, 3-2. So something is wrong with my logic. I can't see anything wrong with moving another step forward though. Like it doesn't. We're checking this. Hold up. 0, 1, 2, 3. Yeah, no, this should be fine. Unless that's not a G. This isn't working, this check. Oh, we may as well print out that too, right? So let's say print current map position. Let's just see what is that position. G W How are we to get G on the first instance and then we... Does it think maybe we're here? And it's like, this is correct and now this is not? Does it think we're... Well, no, hang on. Let's check what's here. Got G. We got G. All right, hang on. I will go through and fix this. Don't mind me. Let's see what we get with this. G to P, G, 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 and we've got a P there. So yeah, we've messed this up. So what we need to do, P is in the wrong spot. This is 1 and 0 here. Let's rerun. I think that's it. I think we did it. All right, so if I remove all these, it will make it a lot easier for you to see what's going on. So I think I fixed it. These numbers mean nothing in the letters. Like these are all incorrect. We got to fix this up. I got to fix this up. So I'll run this again so you can see in the printout like the grid underneath. So here we go. So this is what we're focusing on here. We've got this P, G, G. So what we want to do is move the P from here to where that G is. Okay, so if we swipe down, we've moved it across, swipe down again, and we've moved it across again. Everything else looks the same, so we've got this correct. And then if we swipe again, nothing should happen because we are now at an E position. So what we could do is, if current map position, we can just copy this. If this equals E, let's say, and then I think what I'll do is just put a, you won't, yeah, U1, okay. And then down here, we'll just replace this with, we'll move the player across as well. So that way we can print out the new updated map, and then we'll just say show game over equals true. So we'll run this. Okay, here we go. Swipe forward, and we'll have like a noise or something. Swipe forward, you won. We got to the exit. You just had to walk forward. This is so cool. Okay, so it's working. The next step is going to be a little bit trickier, so we need to do like a rotation. Which means, oh, my dog's going off again. So if the player direction is east, we do these checks. So the way this check works is that all we're doing is adding a +1 to the X value, which is like a column. We're moving a column over because X is a column. So if the player is facing east, let's take a look at this grid again. We add +1 to their position because they're looking here. We say +1. Let's check out what's there. The other thing is, like, what we need to do is if they're facing south, we -1 to the Y position, but keep X the same. We don't add a +1 to the Y to the X. Same if we switch around this way. So I think this should be pretty simple to do. We could, like I said, we can brute force this. We can have all these if else statements in here to get the game working. And this is basically like how like a beginner programmer would build this, right? Like without going into all the theory of the math and stuff to do with like 2D arrays and things like that. There's simpler ways of manipulating these than what we've done here. Generally, you do have like nested for loops when you're working with 2D arrays. So what I want to do now before I go is I actually want to set up a color for, I want to be able to show the exit color. I want to show the screen change color. So in order to do that, the color, we haven't used this enum, this game tile enum yet, but we will do that, I think, at some point. Okay, so what I want to do is if they are facing, we could do it within this. So what we can do is we can add a +1 again. So we can say new color position. We don't need to do it in this section, but we can do it down here. So we can new color position. We got potential it would still be, it would be the potential position plus 1, right? So it'll be, so we've got the 1 at the start, so we say potential position dot 1, potential position dot 0, and I think this is the plus 1 section. We might flip these, we'll see how we go. And then what we need to do is use this position to get, so what I'm trying to do is if the user is on this P and they've just moved to this G, right? I want to grab the next one over in the direction that they're facing. And I want to get, if it's G, then it's going to be a ground color. When the player moves to this G, I want to grab the exit and then change the color of the screen based on that. You'll see what I mean. So the new color will be let tile equal current map, which would be the updated version of the map, which is fine. And then we have new color position 1, new color position 0. So that's the tile. So this will be like the value, the letter at that position. And what I can do here, I'll use the enum just for this. I've got to clean this up, obviously. Tile. Current color equals tile enum color. Let's see how we go. So move forward 1. That is incorrect. No, that is correct because it's a blue. It's supposed to be blue for the, because the walls are blue, right? Oh no, the ground is teal. I'm just gonna go brown for the ground. Brown ground. And then we also need to set this up. Run this code. This code needs to be run at the start of the level as well. So what we may end up doing is this looping between across both arrays to get the user's current position, and then we'll use that to get what they see ahead of them too. There's gonna be some duplicated code, I think. Putting it in here saves on a bit of performance, but I mean, it's not like we've got an arrays with millions of items and we're looping over, so it's probably fine to do it multiple times each tick of the game. So I'm not too concerned with that. So what I will do is like move this down to another function, put this in that function as well, and then we'll just update the current color. Like we'll call the function here like update color or something, and we'll call that at the start, like when on appear as well. Okay. So let's go with, I think I have this the wrong way around, right? So tile. So let's print what we've got here. Got a couple of minutes left. So we go forward. Got W, which is incorrect. Already incorrect. So I think I need to switch these around. Excuse me. I'm off screen. Yeah, so I'll be in a new place soon. I'll have a way better setup. I know I said that last time, a little while ago, but things happened, so. All right, so we've got that wrong again. I should probably print the position as well. New color position, so I can debug where we're going wrong, like where we're at. So we move forward. It's 3, 2 is the new color position. So if we go 0, 1, 2, 3, 0, 1, 2. So this is where we are. This is the new position we're looking at. So we've got ground. If I move forward one more time, we've got 3, 3, which is incorrect. we need to get 4.2. We need 4.2. So 3.3. This is a kind of a weird one because got 3.2, which is correct. Sorry, give me 1 second. We've already got the potential position. I also need to do some checking as well so that we're not like going out of bounds. Like once we get here, there's nothing in front. And I can be clever when I make these maps as well. Like we should have walls around the entire perimeter so that it would be impossible for you to see beyond them. I was thinking of just doing a +2 up here just so we got something working. So like if I grab this, I feel like this is easier for me to reason about. We might need to flip these around. Let's see how we go. So we got the ground, which is correct. We can see the ground in front of us. And we see the exit. And then if we swipe up on the exit, because we're looking at the exit now, swipe up, we should see show game over equals true. If show game over, if no show game over, we'll just fix this crash real quick. And we'll run this. I saw somewhere without using print, we can use debug pointer automatically print in console. Are you talking about the breakpoints? Are you talking about the breakpoints? Okay, so we'll move forward 1 step. I don't want that there. Let's keep going. So we're seeing the... Okay, so let's set the... just so this is more realistic, we'll set it to brown because the position... let's take a look at the grid here. So we start here at the P. And we are here in that array. We want to move to this G, which is the brown spot we're looking at now. We move up 1. Nothing changes. So this is where the difficulty of the game... Yeah, I'll show you a little bit about the breakpoints in a second too, because they just take too long for me to set up. I find it's easy just to type in print, but I'll show you. I think I know what you're talking about. So that's swipe forward. It's still brown. So this is where, like what I was trying to explain, the difficulty in the game is that you can't, the scenery doesn't change if you're walking down a hallway. So could you imagine if this, if we had like a big open space? You don't get to see the map, right? This is basically a maze. So could you, if the exit is here, you go ground here, and then you turn left, you go up here. Like this will be really difficult to navigate around. You got to remember where you are. I won't make the game that difficult when you play along. And we move forward again. So we're in this position here now. So we've moved across to here and then to here, and now we can see the exit, which is a green color. And then if we move towards the exit, we get a, hey, you won, or we go to the next level. So we'll do that one more time. So we see brown because in front of us is a ground, which is brown at the moment. You move forward, we still see brown because in front of us is ground. We move forward again, we see green because that's the exit. And we move forward again and we win. Is that cool or is that stupid? Is it the worst game ever made? That's still something to be proud of. If it's the worst game ever made, that's still, I'm happy with that. Okay. Yeah, so anyone joining now, the whole reason why I'm using this big solid colors and stuff is because what I want to do is make it like accessible and then have sounds playing. You're basically blind walking through a maze. Like you can only sort of vaguely see a wall in front of you or an empty path in front of you. That's the whole point of this. We could probably stylize it a bit, like have patterns instead of just pure colors. Because like if you're colorblind, you might not be able to see the difference between them. So we could have like some stripes, some walls. We'll have animations like if you swipe right or left, it'll be maybe like a box transition, kind of spins around you. But the breakpoints. So what I have done in the past is like you put a breakpoint, you open one of these, you go. We're not going to be able to see this too well on stream. I don't think the text is a bit small. I can't make that larger. You can add an action. So you can say, where are we? We can say temp map. So I can print out the temp map here. Now, if I just run this like this, we're still going to get a freeze, right? The app still stops there, but then we have our printout as well, which is great. However, if you don't want it to freeze, you can just go automatically continue after evaluating actions. Okay, so we'll keep playing. Swipe forward, and then we still get the printout down here too. So let's do that again. Swipe forward. See, I'm getting these here from this breakpoint, which is useful. But you can see how long it took me to like sort of set that up. Like I could type this into here, doing print statements much faster. This can do other stuff as well. I guess you can like log a message. You can have different expressions in there. You can run a script. Never use that. Sounds are kind of cool. You could play a sound, a shell command. And then you can apply different conditions as well. So like you can say if temp map is equal to, and then I put like a map in here or something, we do a break. So the breakpoints are pretty powerful for that sort of stuff, but I hardly ever use them. I just use them to like stop. Actually, I really only just use them to check which branch the code is flowing through. That's all I do. I think that's what 99% of people use them for. And then if it pauses there and you're like, oh, let's print it out, you just you type it down here when it stops. That's it. So yeah, you can go P or you can go PO, and then we can say temp. Oh, we can't say temp map because we broke on temp map. So what we can do is we can say step over into the next section, and we can just go temp map now, and then we print that out. So you got these little controls down here too. So you can hit play to continue execution of the app. You can do step over, so it will stop on like the next line, right? You can step into, so if you're like on a function, it will take you. See if we can make that happen. So it jumped straight up to where this is. So what we can do is jump back out. So it takes us back down here. If I step over and we jump into the print, if we go into the print, it doesn't do anything. I was thinking it might jump us to where this is, like in here, but obviously it's like in Apple code and stuff. I don't think it will jump to a line there. And then we can jump up to show game over. We can go back and we can keep running. You know, we're on the curly brace. We can just keep, you can do little steps throughout your code by this little down arrow button. And then you can go backwards through the code as well using the other one. But we're finished with that. I kind of think that's it. Are you using the new OS log debugging? I am using it in my regular apps, yeah. They are much faster than the print statements, and you can just leave them in your app, right? The print statements you kind of have to remove because they can be slow, but I think you would think by now that the compiler will just automatically remove them. At least that's what I would do. Give me 1 second. All right. Yeah, I think that's it for the stream, really. We're kind of done. If you got questions and stuff, just jump on the Discord and leave them there. I'm on Twitter as well. You can find me with full name. This isn't finished. I was hoping that we would get to a point where like there'd be something completed that I can put this on my Patreon, that people can download, have a play with it. But I think I want to clean it up and get the rest of this grid stuff working and maybe add like one more level. But I think you all get like the gist of it, right? We've got a single direction available to us where a player can move forward. When I clean up the code, I'm going to just like move some stuff into some functions, but I'm going to keep it as... verbose as it is now, because I think this, like, I'll make it a little bit easier to read, but I think beginners coming to these kind of ideas, it would help them. Like, I'm not going to do any tricky math stuff. I was thinking about doing that, like some tricky math stuff, for calculating different positions in the grid. But I think all I'll do is we'll just keep the brute force code in there, and then you can look over it yourself and make better sense of what it's actually doing. But I think that's it for today. I know it was like slightly shorter, but I think I prefer to keep it a little bit shorter because otherwise, people are going to lose interest. Will I do a part 2? I don't think I need to do a part 2. I don't know. We'll see how we go. Maybe we'll do a part 2 when we get to like doing animations and things like that. But anyway, thanks for. Am I frozen now? Wow, that's a look. Okay. Hopefully you can all still hear me. I'm off. Okay, great. And I'll leave you with that face. Anyway, it's frozen on my screen. So because I did a thumbs up accidentally. So so yesterday the same thing happened. So macOS is listening to gestures from the camera, and it will do it'll take like a photo or do like a a thumbs up. And so what's happened is every time it does it, it like breaks OBS. It breaks OBS and then just freezes the camera. So what I can do to fix that? I'll change camera. Hey, how you doing? And then we go back to the. Yeah, okay. Now it's back. Okay, hilarious. All right, see you everybody. Thanks for coming along. I'll try and do another one of these a little bit later. We have a series going, which is all like the astrology app, and then we'll have like these one-off streams where I just like do something dumb like this for an hour or two. You can join in. I will put this code up on Patreon now, so that's what I'm gonna start doing. I used to be on GitHub. I'm gonna start putting it on Patreon now. If you want the code, you just watch the video, right? So you pay me with your time, and I get the view hours up. If you steal the code from the video, that's great. But if you don't want to do that and you just want to download it, just like $2-3 or something. So that's it for me. I will talk to you all